You know when you're looking at a bunch of data, like a shopping list or a budget, and you just wish there was a better way to handle it all? A more powerful way to organize it and work with it? Well, there is. Today, we're demystifying the matrix. And no, not that one. We're talking about a mathematical power tool that turns everyday puzzles into surprisingly simple calculations. Okay, let's dive in. So let's paint a picture. Imagine you're in charge of getting all the equipment for a local sports league. Two different soccer teams, the Wildcats and the Mudcats, just handed you their shopping lists for the season, and it's your job to figure out the total bill for each team. It's a classic organizational headache, right? But as you're about to see, it is the perfect job for a matrix. Okay, so here's what we're working with. The Wildcats need 6 goals, 30 balls, and 14 jerseys. Meanwhile, the Mudcats are looking for 10 goals, 24 balls, and 20 jerseys. Now, you could just start mashing numbers into a calculator, but there's a way more elegant way to handle this. And here's the other half of our puzzle, the price list. Goals are a hefty $300 a pop, balls are $10, and jerseys are $30 each. Okay, so now we have all the pieces. The question is, how do we combine these two chunks of information in the most efficient way possible? This is where we introduce our hero for the day, the matrix. Honestly, if you've ever used a spreadsheet, you're already halfway there. Just think of a matrix as a super organized container for numbers, kind of like a spreadsheet that's built specifically for doing math. It's designed to solve exactly this kind of problem. So what is it, officially? Well, a matrix is just a rectangular grid of numbers. We organize these numbers into rows, which, run horizontally, and columns, which are vertical. And every single number tucked inside that grid, we just call that an elements or an entry. It's as simple as that. Let's break it down really quick. The horizontal lines of numbers are your rows. The vertical lines are your columns. The size, or what we call the dimensions of a matrix, is always described as rows by columns. So a matrix that has 2 rows and 3 columns is a 2 by 3 matrix. And trust me, that little detail is going to be very important in a few minutes. Before we go and solve our big soccer problem, let's start with the basics. The easiest things you can do with matrices are adding and subtracting. And the good news is, it works pretty much exactly how you think it would, which makes it a great way to get comfortable. Now, there is one golden rule here you absolutely have to remember. To add or subtract 2 matrices, they have to be the exact same size. So a 2 by 2 can only be added to another 2 by 2. That's it. If they match, you just add or subtract the numbers that are in the same spot. Top left with top left, bottom right with bottom right. You get the idea. Let's see this in action. Here we have matrix A and matrix B. They're both 2 by 2 matrices, so their dimensions match up perfectly. That's our green light. We're good to go. Let's try to calculate A minus B. And boom, here's how it shakes out. For that top left spot, we take A's -2 and subtract B's 8, which gives us -10. For the top right, it's 3 minus 1, which is 2. And we just do the same for the bottom row. 0 minus 5 is -5, and 1 minus 4 is -3. And there you have it. The result is just another 2 by 2 matrix. All right, let's build on that. What if you wanted to multiply an entire matrix by just one number? Like, say you need to triple an entire recipe. That's where something called scalar multiplication comes in, and it's super useful. The word scalar sounds a little fancy, but it's really just a normal single number, not a whole matrix. So scalar multiplication is just taking that one number and multiplying every single entry inside the matrix by it. It's kind of like doing a find and replace, but for multiplication. Okay, check this out. We're going to take the number 3, that's our scalar, and we're going to multiply it by that matrix B from before. Our goal is to make a new matrix where every single value is 3 times bigger than it was. And there it is. It's really that straightforward. We just multiply 3 by every single entry. 3 times 8 is 24, 3 times 1 is 3, 3 times 5 is 15, and 3 times 4 is 12. Yep, every number inside just gets scaled up by the exact same amount. Okay, we've got the basics down. Now it's time for the main event, multiplying 2 matrices together. Now this one's a little trickier, but trust me, this is where the real power of matrices gets unlocked. This is the move that's going to solve our soccer team puzzle. So here's the crucial thing. You can't just multiply any 2 matrices you want. The number of columns in the first matrix has to be the exact same as the number of rows in the second one. Think of it like this. The 2 inner numbers have to match. If they do, it works, and the size of your final answer will be the 2 outer numbers. So here's the move. It's kind of like a little dance. You multiply rows from the first matrix by columns from the second. To get just the very first number of your new matrix, you take row 1 from the first matrix and column 1 from the second. You multiply their first numbers together, then their second numbers, and so on. Then you add all those little products up, and that gives you one single entry. It's a process, but you just repeat it for every spot in the new matrix. And here is a wild, mind-bending fact that you have to remember. With regular numbers, we all know 3 times 5 is the same as 5 times 3. But with matrices, the order is a huge deal. Multiplying matrix A by B is almost never the same as multiplying B by A. Sometimes you can do it one way, but the other way is just impossible.
All right, theory time is over. We have all the tools we need. Let's get back to our 2 soccer teams, the Wildcats and the Mudcats, and use this powerful matrix multiplication to figure out their total equipment costs once and for all.
First things first, we're going to pop all the equipment needs into a nice, neat matrix. We'll call it matrix E for equipment. See how we set it up? Each row is an item, goals, balls, jerseys, and each column is a team. So this is a 3 by 2 matrix. Next up, we create a cost matrix. Let's call it matrix C. This one is just a single row with the cost for a goal, a ball, and a jersey all lined up. This makes it a 1 by 3 matrix. Now for the magic. We're going to multiply C times E. But first, let's double check our rule. Matrix C is a 1 by 3, and matrix E is a 3 by 2. See? The inner dimensions are both 3, so they match. It's gonna work. And our final answer will be the outer dimensions, a 1 by 2 matrix. 1 row, 2 columns, a perfect spot for each team's total cost. And after you run that whole row times column dance, here's what you get. To find the Wildcats' cost, the matrix did this whole calculation. $300 per goal times 6 goals, plus $10 per ball times 30 balls, plus $30 per jersey times 14 jerseys, which all adds up to $2,520. The truly amazing part is that one single matrix operation did that for both teams, all at the same time. That's the power, one clean, elegant operation. From organizing a simple shopping trip to rendering the incredible 3D graphics in a video game, or even modeling an entire national economy, matrices are the silent workhorses that make so much possible. So the final question is for you. Now that you know how they work, what problem in your world, at your job, at home, or maybe in a hobby, is just waiting for a matrix to solve it?